Welcome, welcome. Good morning. Party on. Party on, Wayne. Logs, I have seen a bunch of them, but let me go through and tell you all the ones I have seen. Let's see. From Logan's movie list. Let's see it. Alright. I have not seen Les Mis. I've seen The Disaster Artist. I've seen Creed. I refuse to watch Boyhood because I've seen the start of it. I watched Her. It was terrible. Life of Pi I saw. Lincoln Lawyer was really good. No Country for Old Men's amazing. Da Vinci Code I've seen. Yeah, it's fine. City of God is amazing. Fantastic Mr. Fox I have not seen, but I really like that director. I forget his name, but he does all the colorful movies. Zodiac I've seen. Creepy but really good. Seven I've seen. Good. Braveheart. Duh. Alien, the original, yep, for sure. Mule, yeah, it was okay, eh? A bit weird. Prestige, that used to be one of my favorite movies, actually. Super 8 was good, kind of creepy weird, but really good. Legion is also weird, but good. A Cure for Wellness, not even heard of that one. Okay, El Camino, I don't know, man. It just seemed like they tried too hard, but it was good. Doctor Sleep, I've not seen that, and that looks like an actor I know. I can't remember his name. So I have not seen Dr. Sleep. I definitely haven't seen Mid-90s. So I haven't even heard of Dr. Sleep or A Cure for Wellness. So I'll check those out for sure. American Hustle, sure. Train to Busan, I saw it was really good. Hell or High Water is amazing. Sicario is amazing. Room, I don't want to watch that crap. That's too creepy. Bohemian Rhapsody, I have not seen yet, actually. Little Women, sure. That's like brand new, though. How do you see that? You downloaded that in 1970 for sure. The Lighthouse, we've already talked about. It's disgusting. Jojo Rabbit is hilarious. Yes, also awesome. The Marriage... Dude, what kind of movies are you into? Let's see, Marriage Story, Lady Bird, and La La Land. Okay. Dunkirk was also so sick. I did see Once Upon a Time in Hollywood. So yeah, anyways, to end that off, I have not seen Marriage Story, Lady Bird, or La La Land. So for all of those... No. I have to see my quarantine and chilled movies. You told me to watch Birdman. I have seen it. I have also seen Arrival. I've seen The Social Network. I have seen Rush and own it on DVD. I've seen Annihilation. I've seen Shutter Island. I have seen Sully. I've seen X-Men First Class. And I have seen Pacific Rim, even though it is ridiculous. So I have seen all of those 9 movies that you posted on there, sir. How was that for a rant? Shoot, new list incoming. That was Logan's list. Maybe Logan can share you that list. I won't share it just in case this is like his personal account or something like that. But yeah, if you want, you can get Logan to post his movies list. There's Mr. Ellis Quarantine and Chill movies, which again, I have seen all of those. But anyways, I appreciate the effort, Logan. Oops. I hit back too many times. Yeah, pretty good list, sir. A lot of good ones on there for sure. Awesome. All right, let's see who's all here based on after my rant. Alright, let's see this. Okay, so I have pretty sure I've seen Paula. Believe, yes. Hello, Paula. I am here, here. Nice. Thanks, Paula. Logan is here. Cam Awesome. Oh, Cam, I see a message where you say, "Did you read After yet?" I hadn't decided if I was going to watch the movie or book. I feel like you've put enough effort into reminding me now. Hey, Zoe. Hey, Wendy. That I probably should actually just watch it. Although I think you're messing with me and I'm going to regret life. Here, I will open up. Oh my gosh, this does not look okay. Dramatic films. Whoa, 89% of people like that film on Google, but it's got a 17% on Rotten Tomatoes. Oof. My goodness, that's... Oh, it's on Netflix? That's what it says, at least. Maybe just on American Netflix, though. Liam, you played poker yesterday? Good man. Bassett, welcome, dude. Welcome. Do I see Max yet? Yeah, hey, Max. Nice to see you, buddy. Looking for Josh. Joshy's here. Love it. Kyle. Kyle, where are you at, buddy? Kyle. I don't know who CC Truth is, unfortunately. Hey, Crystal. Okay, I don't see Kyle just yet, but if Kyle could let me know, that'd be awesome. Paul as well. Would be nice to know where you are, sir. Again, power for the people. I don't know who you are either, so. Let's see. No Paul yet. Crystal I saw. Yalda I saw. Izzy should be pretty... Yeah, he's got the AI, so it makes it easy to spot. David, still not seeing you, I don't think, sir. So let me know if you are here. Wendy, looking for you as well. Never mind, you're there. My bad. I already said hi to you too. Sorry. I saw Bassett. Did I see Batten? I kind of assume that being in the same house, one guy's on, the other one's on, but I shouldn't. Yep, Batten's here. Awesome. Ty. Looking for that Slat guy. S-L-A-T. Better be careful with my pronunciation there. Hey, David. Welcome, man. Somebody want video games played on a walk. No one's going to comment on my April Fool's joke below the what did you do yesterday, eh? It's fine. It's fine. Cam, you're constantly messing with Ty there, eh? Every time he's away. Ty's on TikTok. Lenice, I saw. Welcome. Zoe, I saw. Daniel and Liam, I saw. Benny, I saw. Yalda that was a mean joke. Sorry, Yalda. Jerry, I'm pretty sure I saw you, my friend. Yes, Zoe. Huey, Huey, I'm pretty sure I saw you, Hugh. Hubert. Maca Huey and Cheese. The Hewinator. Hugh Dog Millionaire. Yeah, Zoe, send us a April Fool's joke. Yes. Are you just going to send me a picture of myself? Because that would be pretty mean. Okay, so still no Ty, still no Kyle, still no Paul. Oh, snap. You jerk. I saw that coming. I did, even though it's on delay. I saw that coming. Okay, so I'm missing Ty, Paul, Kyle. Hit me up if you show up. Fools. Okay. Bingo bongo. Well, hopefully you guys had a good day yesterday and were able to stay a little bit away from your computers and screens and stuff like that. Yeah, I guess yesterday we had the message that yeah, we're closed until May 4th. So it means another, the whole month of April here, these next 4 weeks with you guys. We're going to be rocking it like this. Easter will be through there, so we'll have some break and be able to kind of relax away from things a little bit and get away. But yeah, for the most part, we're in this for the long haul. So I'm here. I'm hoping that we can continue this and do things in a way that are going to be beneficial, that you guys can, still keep learning. And again, I've helped a couple people now just one-on-one in teams, and I think it's going okay-ish. They might say differently, but feel free to please ask questions if you need it, because I don't want you guys falling behind. I don't think of this as a total break, vacation, just show up, say I'm here in attendance, and then take off. I'm really hoping that we can continue to learn, and that way you guys have no gaps. So that way next year, again, when you're in grade 12, you're able to rock advanced functions or whatever math you got, or let's just finish this one off strong, right? So either way, I think that'd be a good thing. So if you have any questions about anything, make sure you hit me up. And if your parents have any questions for me, it looks like parent-teacher interviews are canceled as well. So make sure you ask away there. Okay. Let's see what I sent you guys. No, I don't think After is on Netflix. I'd have to go to the American Netflix. Bummer. I can't watch it. That's so sad. Or is it? Okay. What am I looking to do here? I want to do this, but not show you grade 9 math. Cam, okay, fine. Cam says I'm missing out. All right, Cameron, I apologize. I will change my mind, and I will watch the crap out of that movie. Because clearly there's not a whole lot else going on anyways. Okay, so grade 11. I believe I sent you guys 2 notes today, 4.5 and 4.6. Can you give me a message on Teams? Oh, I should open up Teams. I don't have that open. Sorry if you've been messaging me. Teams or in the chat if you have not received 4.5 or 4.6. Hey Ty, welcome man. Welcome back from TikTok, yeah. Let me know how many likes you got on that video you posted. In my class. Yo, my hair is whack today. Let's go. Attendance for grade 11 math. Oh, 1 like. That's pretty good for Ty, man. Not bad. Good job, Ty. As expected. You guys are ruthless. Oh, Batten. Oh, boy. Sorry, Ty. Oh, man. All right. I didn't get any messages about people not having 4.5 and 4.6. But basically, 4.5 is super simple. And that's why I was like, we'll just like kind of quickly skim over it and just look quickly. So if you guys could, if you take out 4.5 just to start. Oh, actually, you know what I should do before that? I haven't been doing lately is asking you guys if you had any homework. So from 4.4, I believe there was all of these questions here. Was there any of those that you guys needed me to take up from the homework in terms of 4.4? Attaboy, Ty. Way to stay positive. Any questions from the homework in 4.4? This was from Tuesday now, so you guys would have had that day yesterday to work on that. Wait, no, Monday. Tuesday was a day off. Got some wacko hair going. Should I green screen it? It's probably a little bit easier to see like this, but whatever. Do y'all got any questions? 4.4 questions. Can you hear me? Oh, I almost typed men. Can you hear men? Cam? No, I don't miss you. Yo, how do I only have 19 viewers? And there is how many people in this freaking class? Oh, 22. Yeah, that makes sense because 3 of them were away. So no questions on 4.4? Zoe's got no questions. Awesome. Seems like you guys had that under control then. Awesome. So yeah, I'll just kind of show you 4.5. Yeah, it's self-defense. Where am I? 4.5. So I don't think I really need to get into this too much. That's why I sent you 2 notes today, because there's not really a whole lot of point doing this. If we know, like if you guys were to do this, right, and I'll just quickly kind of show you what the whole point of this lesson is. It's a little bit over the top, but you remember if I was to fill out this chart and then we did the first difference, right, it'd be -2 minus your -4. So +4 would be 2, 2, 2, 2, 2. The first difference is all the same because it is degree 1. In this case here, right, if we did this, it would be 4. 2 times that squared. So 2 times -2 squared. 2 times 4 is 8. Then 2 times 1 is 2. And then you're going to get 2 times 0 is 0. Hey, Pop. Did that hose work?
Yeah, kind of. Got some pretty bad kinks in it.
Oh, shoot.
All right.
And then 2 times 9 would be 18. So if you do your subtraction there, we'd get -6. 0 minus 2 is -2. 2 minus 2 is 2. 8 minus 2 is 6. And 18 minus 8 is 10. And if you do the second difference, right, you guys already know this, but -2 minus -6 would be +4, +4, +4, +4. So anyways, we get degree 2, and that makes sense. Now, if you do that for an exponential function, you might be like, all right, well, I know that degree 2, if I highlight the little exponent there, right, tells me that the second differences are going to be the same. Sorry, highlight that a little better. This one being degree 1 means the first differences are the same. So you might look at degree x means the x differences are the same, and it might not make a lot of sense. Well, that's the thing, is that you could do this all day long. So 2 to the -2 is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2, 4, and 2 to the 3 is 8. And you could do your first differences. And if you subtract these, you'll get 1/4, 1/2. You get 1, 2, and 4. If you do these again, you're going to go, okay, 1/2 minus 1/4 is again 1/4. And then those a half, and then again you're going to get 2 minus 1 is 1, and you get 2. And basically you see that the pattern is staying the same. If I had extended this, like if I had more x values here, you'd basically just see that the quarter, half, 1, 2, 4, 8, quarter, half, 1, 2, 4, quarter, half, 1, it's just getting bumped down. So the pattern will never end. Basically, you could do the 1,000th difference. You could keep going forever, and it would never end. Never end. And so what is the pattern? How do I figure out if I just gave you a table of values and I said, what kind of function is this? Well, basically what you need to do is if it's looking like the pattern is repeated, like this one is, then you go, shoot, you know what? I'm pretty sure this isn't going to be, a polynomial. These ones here are polynomials. Instead, this thing might be an exponential function. And so the way to figure that one out is you look at basically the differences in your y values, and you look at them as multiplication, which totally makes sense, right? In this case here, this is times 2, times 2, times 2, times 2. And because it is multiplication instead of adding, right? For the polynomials, you're always adding something, but because it's multiplication, that's how you know. And that number there is actually going to be working out so that it'll be our base, which is pretty sweet. And that's kind of where we are going to get to by the end of this note. But for the most part, what we're really looking at here is this multiplication as you're going through. That will be your base, that 2 in here. If you're multiplying something by 1/3, then that would be your new base. So we'll make a little note on that. I'm just going to let you guys copy that part down. Maybe I'll see if I can zoom in a little bit better for those of you that don't have full screen. So just hit me up in the chat. Give me the newt or whatever you'd like when you are done getting that sucker down, and we'll rock and roll. That's pretty well the whole message with 5.4, and that's why I gave you 2, or whatever this one is. This is 5.3? I can't remember now. Whatever it is, or 4 point. We're on unit 4. Benny wrote H. What does H mean, Ben? Does that mean you're good? Logan wrote H. Zoe's got a penguin. Daniel, give me a thumbs up. Love it. Love it. Let me just get a few more people in here. So you guys cool with that? The main message here is polynomials. They're going to be a first difference for degree 1, second difference. And basically what that means is you're adding something, right? We're adding to. And then here you couldn't see it at the first degree, but you see in the next one, there's 4 difference in the second one. But yeah, Liam, basically the reason that we're multiplying is like it's 2 to the x. It's just that's the pattern that we see. It's not like why are we doing it? If I see the pattern where it is multiplied, that would tell me that it would be an exponential function. So I'm just going to add a little small note. I don't know if you guys want to type that in here. Polynomials have differences, whereas exponential functions will have basically a product, will be a product, which means multiply, of the previous number. I can't type. Previous number. So if you just want to add that as a little note, exponential functions product be like times 2 or times 3 or whatever it is for everyone. And that kind of makes sense because that's what's happening, right? It's doubling or whatever it would be. So I'm just going to give you guys another minute. Polynomials. It's like a bird, like a parrot is saying polynomial, like if your mailman was a parrot. That's not what it is. It's polynomials. It's like a parrot that doesn't get to eat anything. That's kind of animal cruelty. Don't think like that. That's mean. Okay, I got a GGWP, a whereas in one word assert. Oh, sorry. Ben is correcting me saying that whereas is one word. Ooh, fancy. Didn't even get underlined. Thank you, Benjamin. You must have been doing Literacy Day well yesterday. Just waiting on anyone to say that they are done that, but I think you guys are probably pretty decent because I have not heard anyone say yes or no. Maybe I forgot to ask you guys if you were good. Anyways, basically what you would have noticed here, Daniel's giving me a thumbs up. In all of these, into your 2 to the x's, these ones, basically you'd notice that it would be like times 2, times 2, times 2. If you were to do this, and I don't need to do this for you guys because I think you guys are smart enough you'd figure this out, but these ones would be like, oh, it's times 4, times 4 as you go through. And these ones would be like times 7, right? If we were to put in those values. But anyways, I think that's probably a waste of your time because we're going to do transformations in a second here anyways. So what's the point? Tells me what the base is. Oopsies. So we don't have to do how are these graphs similar. Basically what you'll notice, and we've already done some graphs of exponential functions, and that's why I don't want to like waste your time on this. But for all of these functions, if I graphed 2 to the x, 4 to the x, and 7 to the x, what do they have in common basically is if I was to grab, let me just grab Desmos for a second here. What you guys can see. If I graphed 2 to the exponent x on there, 4 to the exponent x, and 7 to the exponent x. For all of those, you'll notice that, yeah, they got some differences in maybe their like slopes at certain points, but they all have that asymptote at 0, right? They all are going to have that asymptote at 0. And it looks like, as you can see, it makes sense, right? Their y-intercept, which is when x is 0, will all be 1 because 2 to the 0 is 1, 4 to the 0 is 1, 7 to the 0 is 1. And so for all 3 of those graphs, your y-intercept is 1 and they have an asymptote at 0. So we've already kind of discussed those things. That's why we don't really need to get into it too much. But what are the graphs? How are they similar? Basically, they would all have, that says all have a y-int at 0, 1, and they all have asymptotes at, and it's that horizontal line when y is equal to 0, right at the x-axis. So I'll just give you guys a minute to write that down. The constant ratio tells you the base. Right, and you guys could you could input those values if you wanted, but not really a need. Four to the negative 2. 4 squared is 16, so that'd be 1 over 16, 1 over 4, 1, 4, and 16. What is this? 7. So it'd be 1 over 49, 1 over 7. 1, 7, and 49. So each of them you can see that they're basically multiplied by that number every time you go through. And that constant, if we had took our time there, you would see, oh, this is times 2, right? A quarter times 2 is a half. Half times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. Anyways, you're going to get that as you go through, and basically, yeah, you'll see that in there. Sorry, I've just got a quick message. So sorry, I just had a question, and I'm a little bit late getting to it. It was 7 minutes ago. I don't know why Teams is not being very good with notifications for me today, but somebody said back in that first example, let me just show you guys back in that first example, up here, says, for these ones, if they have exponents, like why are they not exponential? Because basically the difference with these ones, right, is that the x is in the base. It's like, it's the base there. And so these, remember, these are polynomials. Polynomials is like x squared, x cubed. But this over here is different. This is not x in the base, right? This one has a number in the base, and x is in the exponent. And when x is in the exponent, that's when it's an exponential function, because x is in the exponent, instead of being at the bottom here as the base. These are polynomials when it's in the base. That's a good question. And then this one over here is your exponential function because it's in the exponent there. So that's the difference. These are polynomials because the x is in the base, and that's why these ones are adding, or the first difference, second difference, and that's why this third one here is multiplying, because it's an exponential function. Just like all these ones, all three of these, right, they have the x in the exponent. 2 to the x, 4 to the x, and 7 to the x. All of them have the x in the exponent, and so they're all exponential functions, and so that number that gets multiplied through every time to each of them would be your base. I wonder if I should green screen this, because I am taking up more of that than I planned. More of the screen. Okay, so there's a lot of writing on there. Does this seem like review to you guys, or do you guys want me to be doing like more descriptive stuff? Like I planned on just like rushing through this stuff today because I felt like it was a lot of like, you know, basic review, but maybe you guys are like, whoa, what the crap is happening here? And you need me to slow down. So I think it's review, and if you're embarrassed about that, maybe shoot me a message in Teams. But I'll probably go on a majority there because this stuff is stuff I feel like I've talked about. We talked about how, you know, you've got an asymptote. We talked about how exponential functions all have y-intercepts at 1. We talked about not the idea of multiplying each time, but that's where that base comes from. That's the only thing we've really learned that's new. You guys should be able to do these table of values and stuff like that. So I'll just wait until I see a message on what somebody's opinion of things are. All right, well, I've got one Teams message, and they're asking me to be a little bit more descriptive and slow things down, and none of the rest of you guys are inputting things. So I'm going to be a little bit more descriptive and then take some more time on this lesson then. So I apologize if that's the case. I guess maybe I overthought today. Maybe I thought we would just rip through, but maybe some of you guys just don't care, so that's fine too. So basically, what have I got here? I don't need to really graph these because you've got the y equals x line. This one you've got the parabola, and then this one over here you've got the shape. We know what 2 to the x is, but maybe what I'll do is I'll just graph these ones quickly so that way you guys can see where they are. So basically, if we were to graph this sucker, just so we can put some points down, if you want to graph these with me, draw your x and y axis. And what are my y values? They're a bit nasty. It'd be nice to go up to like maybe at least like 7. So am I going to get up to 7 on my y axis? 1, 2, I think for sure, right? Yeah. Nice to maybe even go up to 16. Maybe I'll go up to 16. So go by twos. 2, 4, 6, 8, 10, 14, 16. 30 and 32. And then I think our x values really only go between 0 and -2. Sorry, 2 and -2, I guess. So all of those points are in there. Great. We'll be able to graph every y value except for this one that's the 49 here, right? That'll be the only one that we really won't be able to get. So we'll get that sucker in there. So yeah, basically, let's graph our points. So -2 will be at a quarter. So here's is 1, right? And I know that all of these graphs go through that point. So I'm just going to draw a little tick there, but that would be 1. So at -2, a quarter, it'll be like, you know, pretty darn small. It doesn't have to be perfect. And then I know -1 was a half. I know this one went through at 1 here. The next point would be if I'm just going off this first graph here, right? I'm going to graph this one in black, do different colors for the other ones. So black will be y equals 2 to the x, right? And then when x is 2, y is 4. So I'm going to get something like that. And if I connect my dots there, oh, sorry, I forgot the point 1, 2. And it would look something like that. It's hard to know exactly without more points, but that would be the point 2 to the x. So maybe I'll just go over those points and make them a bit bigger. Basically, these ones are so small in here, though, that it won't really matter for us a whole lot. Got another Teams message, and it's not. Yeah, okay. I've got 2 messages in Teams. There are people are saying, please don't rush it. Please don't rush it. So anyways, no one else has been descriptive in that sense, so I will, yeah, definitely slow things down a little bit. Sorry about that, guys. So I've got y equals 2 to the x in there. With how pixelated I am, I have a couple people in my grade 9 class say it looked like I was like getting like Thanos snapped away and like slowly disintegrating. I also love, I posted, I miss you guys in the chat, and no one said anything. No one. It's fine. I know Logan misses me because he made me a playlist of movies. Thanks, Logs. 4 to the x now. So we're going to graph these points on 4 to the x. Let's graph them in blue or something like that. Blue. Thanks, Zoe. Feel like I'm being a whiner. The blue one, so we'll graph, again, it'll go through the point 1. You guys see that goes through the point 0, 1 here. And then it goes 1, 4, 2, 16. We'll graph these nasty ones in a second. They're pretty gross, right? But we'll graph the point 1, 4, and 2, 16. 1, 4, and 2, 16 is way up there. And the reason I wanted to graph those nasty ones is because, sorry, I want to graph them later, is because 1 quarter and 1/16, like if we look at my graph, right, when we have y equals 1, a quarter and a 16, it's like, it's going to be lower than the black ones, isn't it? But like not by much. So I don't know, it's really hard to graph it in that sense. So I'd maybe just like, don't worry about those ones so much. The big deal is that this thing is never really going to go too negative. I should make those dots a bit bigger so that way you guys can see in the video. Oh, I just like, yeah, my eyeballs disappeared there. But anyways, you connect your dots. And let's see, how do I do here? That was decent. And that one is y equals 4 to the x. And really the reason that we're graphing this is that you guys see now that basically the higher that exponent is, sorry, not exponent, the exponent's always x, but higher the base is, so 2 to the x, it's like meh, 4 to the x gets even steeper. And I think you guys could probably tell that as we graph the next one, sorry, let's make that dot a little bit bigger, it's harder to see on there now. And I'm going to wait a sec because I know some of you guys want to write that graph down. But as we're about to go and graph the next point in there, or that, I think it was 7 to the x, it's going to be crazy steep, right? I know that it's, if I graph this one in red, this next one, this would be 7 to the x. I'm just going to make that red dot up there. So this would be 7 to the x, right? I know just looking at my points, it still also goes through 1, right? Because 7 to the 0 is 1. Perfect. 7 to the 1 is 7. So 7 is in there. But then 7 to the 2 is 49, right? We don't even get up to 49, our graph. So it's crazy steep. You can already tell it. Just like when x is 2, it's way up off my screen, right? It's just too high. Sorry. When x is 2, I had my mouse on the different part of the screen. But anyways, when x is 2, it's way, way up here. So it's too high for this. But you get the point. We also would look and go, okay, well, at -1, it's 1 over 7. So that's really small. And -2 is -1 over 49. Or sorry, 1 over 49. So basically, right, just, it doesn't have to be perfect, but just draw it along the axes there. So just draw them all. They'll all be following along like that. And you go through and something like that, and it would just go up, 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 up. And that is y equals 7 to the x. So hopefully me slowing this down, at least you've got the graphs down there now, and you can just know that basically it's gets steeper as you go. So how does the value of the base affect your graph? Maybe you just type it right. The larger the base, the steeper and faster the slope increases. Increases. Just checking Teams again. I've got another message. Oh, Paul says he is here. Hey, Paul. Welcome, welcome. I believe, yeah, I don't remember if I updated the attendance. Let me just go back and check. No, not yet. And I'm still missing Kyle. Start of class. Save. Kyle, if you're there, buddy, let me know, because I don't think I saw you. Okay. And the domain and range of all the graphs should be pretty well the same, guys. We know that the domain, because it does go forever, there's nothing x can't be, would be XER, right? It goes on forever. And then our range, basically, if you think about this, right? If I put in, even like, so for like 2 to the x here, if I put in like a number that's super negative, like way out here, like 2 to the -100. Well, if we remember our rules, our exponent rules, remember that basically just takes 2, makes it 1 over 2 to the 100, and that becomes 1 to the 100 over 2 to the 100, which is not 0. Basically, the thing will, oh, sorry, you can't see what I'm writing because it's behind my head. But it'll never become negative. It's not possible. It'll just be 1 over like this, like, disgustingly large number. You could say like infinity or something big like that. So it'll just be close to 0, right? 1 over 1,000, 1 over a big number, it gets closer and closer to 0. But it'll never actually touch 0. It's always going to be 1 on top, no matter what you do. So I am going to say that our range is YER, but, and we're going to talk about this in a second, they go close to this thing that's called an asymptote, which we've talked about when we did our reciprocal functions. but our y values will be greater than, not equal to, just greater than 0. I am just going to grab a granola bar because my stomach is like grumbling like crazy. Just kidding, I found cookies. Okay. And the x-intercept doesn't exist, right? Not going to happen. And they all have the same point in common. They all have a y-intercept. Liam, they are chocolate chip cookies, although they are gluten-free, because the girl I'm seeing is gluten-free, which is, well, it's fine. Just makes cooking a little less fun. They're homemade. Yeah, Cam, I'll show you a pic. Here, I'll bring it up right now. She's super cute. Sec, I gotta find a better one. Dang it, my joke is not doing so well. I can't find a good picture. Dang it. I was trying to find a picture of Michelle Obama, but like there's literally no freaking pictures that I can do full screen. Anyways, that was my April Fool's joke, but it was terrible because I couldn't pull it off. Shut up. I'm not even going to look at the comments because you guys are probably just ruthlessly tearing me apart. It's not Google. Okay. Cam, I'm not going to show her because this is like all recorded. And that'd be weird. Yeah, you did call that good. I feel like most people aren't even paying attention, though, so it's probably fine if I show you. All right, I'll show you. This would be like a reward for the people that are still alive. Logs doesn't want me to. He's looking out for me there. All right. Ty, welcome back, bro. Oh, I got to do attendance. Whoa, 2 messages on Esme now. Man, oh man, oh man. Where are you, attendants? Good job, Logan. And Ty. Oh yeah, dude. Wait, who? What? Oh yeah, I already fixed you. Ty, I just went on like a friggin' mission. I don't know why you're saying, "Are you alive?" Oh, it's because I was saying like no one else is talking to me. Okay. If people are still with me at the end, I'll show a picture. We'll see how it goes. I've always been British. British and Danish. Frig, let's get this friggin' lesson over with, eh? Okay, so these ones, the half x and all that sort of thing, if we put in our x values, right? So this will be 1/2 to the -2. And remember, you do your reciprocal. So you flip it. So this would be 2 to the +2, right? You flip 1/2, it becomes 2 to the +2. And that would just be 4. So it's just kind of reversed. And if we do 2 to the -1, I'll keep these things in line. Right? 2 to the -1, that would be basically 1/2 to the 1 would just be, oh, sorry, what the heck am I doing? It's 1/2 to the -1, not 2 to the -1. So anyways, you'd flip it, so it'd be 2 to the 1, right? And so just be 2. And then 1/2 to the 0. Anything to the 0 is just 1. 1/2 to the 1 is 1, and 1/2 to the 2 is 1/2 times 1/2, which is 1/4. So one thing I just want to point out to you guys is if you look at those values, the 4, 2, 1, oopsies, 1/2 to the 1 is 1/2, my bad. That was weird. So if you look at those y values, do you notice that it's just the reverse? Let me just scroll up for a second. You can pause it if you really need to get that sucker. 1, 2, pause. But up here, they're kind of the opposite of this, right? 1/4, 1/2, 1, 2, 4. Scrolling down. 4, 2, 1, 1/2, 1/4. It's the exact opposite, right? Things are just reversed. And if we look at this now, how do I go from 4 to 2, right? Well, I'm multiplying it by 1/2. 2 to 1, multiply that by 1/2, and so on. And that pattern repeats, right? It's the same thing over and over and over again. And so that helps us determine what that pattern would be. And I could also have that same idea for this 1/3. Did we do 3 to the x last time? No, it's 4 to the x. It'll be a little bit different. But if we look at that 4 to the x and 1/4 to the x, those values would be different. Maybe I don't need to do that 1/3 just yet. But if we do this one, this would be 1/4 to the, oops. Not very good at this teaching thing today. 1/4 to the -2, flip the inside, right? It'd be 4 to the 2, and 4 squared is 16. This would be 1/4 to the -1, flip a quarter, would be 4 to the 1, be 4. 1/4 to the 0 is anything to the 0 is still 1. 1/4 to the 1 is 1, and 1/4 times 1/4 is 1/16. Sorry, I don't know what the heck, I keep writing 1 in that second one. And so again, basically what's happening there, okay, so what did I multiply 16 to get 4? Well, I multiplied it by 1/4, and this by 1/4, and so on. You can kind of see where that pattern is coming from there every single time. So I won't do that middle one. Maybe I'll just leave that one up there for you, and that one over there, because I might have missed it. I haven't asked for the thumbs up in a while. Can you guys give me a thumbs up if you are done copying this or still with me? Or again, I didn't really get a lot of feedback on whether I was going too fast, too slow for some people. I only got up too fast. So that's why I'm doing it this way. If you are annoyed with me, stick up for yourself more. Zoe's all good. Awesome. Cam is. Daniel, give me a thumbs up. Leon, give me a thumbs up. Thanks for the dab. Logs. Batten says I'm a snail. Too late, Batten. You should have told me that like 10 minutes ago, bro. Jerry just says I'm a little slow with a cat in a box. Is because cats getting out of boxes are a slow process. Isaac, if you want to see the amount of dislikes that a person can get on a YouTube video, go to my first period's friggin' video. Here, let me open it up for you. It is ruthless. Those grade 9s absolutely despise me and everything I stand for. If I was to send you this video, click that if you can. I don't know how you click it, but if you open that, anyways, if you open that video, I believe it should work. I don't know why mine said error before. Yeah, how many likes and dislikes on that? It's absurd. Oh, 9. A few kids, they felt bad for me at the end because I was fake crying. But, yeah, anyways. Brutes. Killing me. 9 dislikes. They always will just, like, all spam the dislike. I had 13 at one point. Yeah, 8 or 9 there. But yeah, I had 13 at one point. I think a bunch of them, and it was no likes. They switched it over. Anyways, and then remember, there's only like 18 kids in that class. Oh man, oh well. So I've lost my train of thought, but we're over here. And so we'll just graph the two of them. So if you guys want to help me out, we just need to go up to like 16 again. So maybe I'll just do an X and Y axis here. -2, -1, 0, 1, 2. And again, I'll go up to 16. So this first graph, right? I'm going to graph this one in black, I guess. I don't know. And so if we look at our points there at -2, it's at 4. -1 is at 2. We go 1. And then we go down from there, right? It'd be a half and then a quarter, like really small. So you connect your points. And you might notice that it's just like we said, a reverse of the last graph on the original page there. So y equals 2 to the x. Oh, sorry, that's 1/2. My bad. What a jerk. And if you guys remember, these are like base values that are exponential decay, right? It's actually decaying and going down, and that makes sense because we've got a half in there. And all these ones up above, right? All these ones up here were all exponential growth because the bases were bigger than 1. But here, this is exponential decay because it's going down. And then I could also graph 1/4 to the x, right, which was these values here. So I know at -2 it's going to be 16, then 4, then 1. So let's just do that. I'll graph that in red, I guess. Something like that. So it'd be 16, then 4, then it'd be 1 in the same part. Then it'd be a quarter and a 16th. And basically it's just going to be same idea following that line there. So I'll just connect my dots, try and do better than I did with my line last time. So that's y equals 1/4 x. Oh, that's some sort of weird notification. I think I'm still there, still alive. You guys are with me? My streaming software was being weird. Okay. And then let's just answer a couple of these questions. Sorry for those of you. We're almost done. How are these graphs similar? Well, basically, they're all exponential decay. They all have a y-intercept, again, at 1, at 0, 1. So that's the same thing as before, right? And they all have a horizontal asymptote, or an asymptote in general, at y equals 0. So basically, if you look at what we compared with these ones as the ones above, you'd notice that they have the exact same things in common, right? They all of the graphs, the ones we graphed up above, the ones we've graphed here, they all have y-intercepts at 1, and also they all have an asymptote at y equals 0. And again, what does the constant ratio tell me? Well, you see here, these things lined up, right? All these things are the same as the base here. All these are the same as the base here. So basically, what does the constant ratio tell you? It tells you the base. How does the value of the base affect your graph? Well, basically, get them. Basically, you're going to have right, the same idea as before. The smaller it is towards 0. In this case, though, like the greater the denominator, the steeper the graph. And then what is the domain and range? Well, it's going to be the exact same thing, right? Not even just for these two, but even the ones up above. Same thing. The domain is everywhere, and the range is all real numbers, but again, they have to be greater than that asymptote. Sorry, not greater than or equal to, just greater than. And they have no x-intercepts because there's no way that graph is ever going to touch the x-axis. So I'll give you guys a minute to copy that down. This will pretty much be it. I'll just do a little summary in the bottom here, but yeah, as you can see, as the slower I go down on that, tends to take up our time. No homework from last night to take up, so that didn't hurt. Lunchtime soon. Let me know when I'm good to wrap this sucker up. You guys got this copied? Let me know when I am good to wrap this sucker up. Y'all says she's good. Daniel's all good. Love it. Love it, love it. All right, all right. So basically, all these graphs have one point in common. They're all the y-intercept, sorry. And then just, oh yeah, and I will not forget, Cameron. Good memory. You will not let me get away with that, eh? All right. So basically, a asymptote, right? We've already talked about this a million times, but it's another place to have a good definition of that. An asymptote is that line that the curve approaches, right? It gets really close to that horizontal asymptote, that x-axis, but it never actually does touch it, and on any part of its domain, right? So even as we go out to infinity out here, and both of them have it, right? So exponential functions, when they're just like this, tomorrow we're going to do transformations. Okay, so it's not okay for me to just say always exponential functions have a horizontal asymptote there. It's just like, remember when we did reciprocal functions? And we said, okay, like, you know, the reciprocal function had a horizontal asymptote like this, and then they kind of did their squiggles, and we're like, all right, there's the properties of them. And then we moved those asymptotes, right? You did like a shift left or a shift right, and we did transformations. So we're going to do those transformations again with these exponential functions. And so that's our goal is to do them with exponential functions. Tomorrow, do a little bit of transformations and not overly whelming. I think you guys can still apply the same skills you've had, but we'll be able to apply them a little bit differently. It's good. These are the problem with exponential functions is because you can have a different base and each base looks different. We haven't actually transformed anything yet. These are just like, this is 2 different parent functions, and up here these are 3 different parent functions. They have no transformations. They don't have an a, k, d, or c yet. They're just like 2 to the x is one function, one parent function, and then like 1 over 2 to the x is a different parent function. And so anyways, all a little bit different. So just as a quick little wrap up, what did we learn? We don't need to fill in this chart. That's just like talking about the domain and range of a linear and quadratic. Like, you guys know that crap. But basically the big thing is that these exponential functions, right? It's not like some sort of like, I'm going up by 1, or in their second difference, it's all adding 2 at the end, right? So it'd be our second difference. There's not a constant amount. Here, what's happening is you're multiplying each one, and that's kind of the big deal. Basically, we saw a few things. This is like the key ideas from today, right? We know that you're having increasing things, so like 2 to the x, 4 to the x, if that base underneath, and we called it b before, but c, whatever, is bigger than 1, and if it's between 0 and 1, like a half, a quarter, it was decreasing. So we called that exponential growth. If you just want to write that underneath, growth and decay. Growth and decay. So anyways, you get your exponential growth, exponential decay, all that sort of stuff. They never have any x-intercepts. They always have a y-intercept of 1. No x-intercepts. They always have a y-intercept of 1. And they always have that horizontal asymptote at y equals 0. So all important things, just general stuff before we get on and work through our bigger problems tomorrow. So in terms of what we could do to practice this stuff, let me just give you guys a couple things here. I won't overwhelm you. It's already 11:20, but you still have 15 minutes. Just so you can see if you fully understand. What are we at right now? We're in chapter 4. I believe this is 4.5. So number 1 is really good because so we're going to do page 243. I won't give you too many. Page 243. So I like number 1. Basically, number 1, you're not going to be able to see it on here, but it's going to give you a couple table of... Oh, yeah, it's just going to make it go invisible. I got to switch my camera. Number 1 is just a couple table of values. It doesn't tell you the equation, but you're going to have to look at those table of values and do, some of them might be linear functions, some of them might be quadratic, so do your first, second differences. And if that's not working, right, if you notice in your first differences, your second differences, they are all multiples of each other, well then maybe you figure out what it multiplies by, basically you'll be able to figure out what the base of the exponential function is. And Zoe, it's a great point. I'm not giving you any out of class work. How's that? I just want to give you enough work so that you can practice a couple of these for the last 15 minutes. So I won't call it homework anymore. We'll call it fun work. Just a chance to practice, right? So I'm not going to overwhelm you. I think just number 1 is a good example. I don't need to give you number 2. It's just shapes. Ooh, I just said that and then... Let's just do number 2 because it's shapes, but you could tell me why. Your explanation, I want you to explain using properties. Explain using properties. Okay, so it's only 2. That's pretty good. Anyway, Zoe, you can hate me for giving you extra work at home. Just a couple. And just so we're clear, that is all of the questions from that section. So it's not like I was really that nice to you guys. Cool. So I have no Teams messages, but I do have, and you guys also have 15 minutes here. So if you have any messages, shoot me a message in Teams, and we'll rock and roll from there. And I can help you guys one-on-one with any of this stuff. If you had trouble getting something, we'll rock and roll. Syra, welcome. Welcome. Yeah, you can totally do those questions. Here, I'll just show you on the camera here. We'll do the old full screen. I'll show you little dirt bags which questions you're doing. And those of you that don't have this, just pause the freaking video when I show you, and then there's no excuses. All right, so there is number 1. Pause that if you need it. And there is number 2. Syra, how did you even get this video? How'd you even get, did people send the links of this crap? And there is number 2. So all you're doing with number 2 is you're just, and again, you can pause it there or whatever, but yeah, your goal is so you can get the, tell me what kind of function it is and tell me why. So that's it. That's it. Yeah, so I hope that is pretty easy today. If you're struggling or if I went too fast or something like that, let me know, and I can give you a more completed note. I can send you like the fully completed note from me, because I think it's more like looking and properties and stuff like that. So just ask away, and I will help you out with that. All right, so I'll just wait around for a minute to see if anyone has any questions or anything, but other than that, we are good. Yeah, tough guy. Light work, eh? Zoe, I'm not forgetting something. So there's your homework again. Here, I'll show you. Ready? It's going to be quick. Are you looking? It's going to be very fast. That's it. That's all you get. There you go. Now do your freaking homework. All right. Homework check tomorrow. I got 20 viewers, and one of them is someone who graduated 2 years ago. So I know some of you little dirtbags did not stay here the whole time. Well, I guess, who am I talking to? I'm talking to people that are still here. That means nothing. All right. Okay, that's great. As long as, I don't understand, as long as Bassett isn't there. Oh, he means for making the soccer team. Nah, man, Bassett's got to be there. Bassett's got to be there. Who else? Who else is on the soccer team? David, you're going to do the soccer team. All right. Daffe's on the team. David Kenoshi. All right. All right, homies. Yeah, Yalda, you're going to be on the team. Liam's on the team for sure. Liam, you don't mind being goalie. Cam, you can be on the freaking team, except now there's a girls' team. Well, I hope all this stuff still runs, but so you'll probably play on the girls' team. I was hoping you'd play on the guys' team. Daniel, you don't have to do soccer. Yeah, it's probably true, Zoe. It could be. I'm not totally sure. I'm just trying to stay positive. Most of the time, we don't even get a chance to get on the field until May anyways. So if we do go back in May, if that's possible, then that would be when we start doing practices and whatnot, and the season starts like mid to late May anyways. Soccer season's so fast. A lot of it's in April. Oh, you already got any? Yeah, they haven't even told me anything about soccer yet, so it's crazy they already canceled all the track stuff. Probably going to OFSA. We're so talented at everything. Okay, team. I think I will probably make lunch. Oh, I have a message on Teams. Is it somebody that wants help? Whoa, that's a long message. All right, team. Yeah, I'll end her there, even though there's 19 of you still hanging out. I was just reading messages from people and whatnot. See ya. See you, Jerry. Miss you, Jerry. See you, Zoe. You have a good lunch, too. With 4 H's. See you, Josh. See you, Bassett. See you, Joshy.